in the long term, which is my ultimate goal. I need to be good long term. So it's like short-term pain for long-term gain, but that's what I have to go through right now. So anyway, thank you again. I asked you for today to get question 3 done in your packets on page 23. So let's open up to that. I want to see if you were able to do this on your own following the process. Should not have been a big deal because it was just like the other ones that I showed you how to do on the video that you watched on Friday's class. So let's make sure that you did it correctly. Then we'll finish up the questions in your packet dealing with angled projectiles, and then we're going to do a PhET simulation lab with an angled projectile. This will complete the unit, which means that for tomorrow, you have to get pages 27 and 28 done to get you ready for the quiz on angled projectiles. And then tomorrow, I will give you the review assignment to get you ready for the unit test. The unit test on this I'm planning will be on Monday next week. All right, so you'll have until Friday to get the review done, and I'll tell you about that review tomorrow once we have quizzed on this. All right, so let's take a look at page 23. Make sure that you're all good in understanding what you were supposed to do. Okay, so on page 23, the first thing you should have done was made a sketch, and your sketch should have looked like this, where you've got your initial speed at 100 meters per second. You've got your launch angle of 30.0 degrees. You should have showed the dx, the dy, and the t. Up here at the highest point, that would just be the time going up. Then what you knew you were supposed to do was to resolve that initial velocity into its components in the horizontal and vertical directions. So to get the horizontal component, you should have used AX is A cosine theta. So that would be 100 meters per second times the cosine of 30.0 degrees, leaving you with 86.6 meters per second. In the vertical direction, you should have used AY as A sine theta, 100 meters per second times the sine of 30.0 degrees. And that gives you an initial vertical velocity component of 50.0 meters per second with the sig figs. Now you would take this and go ahead and make your chart. And what we know in the X direction, A is 0 meters per second squared. In the Y direction, it is negative 9.81 meter per second squared. The VI in the X is 86.6 meters per second, like you found here. In the Y, the VI is positive 50.0 meters per second. You do need to make that positive because in the vertical direction, it changes direction of motion. It goes up and then it comes down. So you absolutely have to have that positive sign there. The D and the X is what we're going to look for. There would have been a question mark there. The D and the Y we were looking for. There's a question mark there. These are the final answers for those. And then you had to get the time, which we would figure out. Again, a question mark. We know that the VF at the top is 86.6 meters per second in the X direction. That does not change. In the Y, it's 0 meters per second at the top. So the first thing we're going to ask you to find in this question is dy. But before you can get the dy, you have to get your t. So I'm going to do that first using the vertical direction. Using VF is VI plus AT. So T would be VF minus VI over A. In the vertical direction, it stops at the top. So the VF could be 0 meters per second minus the positive 50.0 meters per second over negative 9.81 meter per second squared. That gives you a time up of 5.10 seconds, which means you're going to double that to get the total time of 10.2 seconds. Then I went through and I figured out what D in the X direction is using D as VIT plus 1/2 AT squared. In the X direction, the A is 0, so that drops out. So I would take the 86.6 meters per second, multiply by the total time of 10.2 seconds to give us 883 meters for the total range. Now you have to get the height. And the way I did it in this problem was using V bar as D over T. But V bar in the Y direction is not 50.0 meters per second. It's the average of 0 and 50, which is 25.0 meters per second. So the D is V bar times T, 25.0 meters per second times 5.10 seconds, which would give you 128 meters. You could have also done it using D is VIT plus 1/2 AT squared, which would have given you the positive 50.0 meters per second times the time going up, which we said was just 5.10 seconds, plus 1/2 of negative 9.81 meter per second squared times the 5.10 seconds. And you would square that. And if you work that out, you should have gotten the same answer of 128 meters for the vertical height. Okay, any questions on problem 3?
Yep. Or, calculate for the maximum height.
Yep.
What's the precise answer?
128 meters.
Like, I don't know why, but I have 127.
Okay, you have sig fig error. It's got to be 3 sig figs because of the initial speed and the time.
If it's like I want 127.4.
Which way did you do it?
I did D equals V plus 1.
Okay, so let me check my math. 50 times 5.10 plus 0.5 times negative 9.81 times 5.10 squared. You are correct. So if you did it this way, you would have gotten 127 meters, but not 127.42. It's got to be with the proper sig figs, 127 meters, if you did it that way. Okay? Anything else? Yep.
Why did you use the 5.10 for the DY?
Here?
Yeah.
Because I only want the distance going up. The time up is half of the total time. Okay? If you use 10.2 seconds, your dy would have been 0, which would have meant it started on the ground and it landed on the ground. That's a sign that you have the wrong time. Otherwise, it didn't go up off the ground at all, and it does. Anything else? All right, then let's go to page 24 and let's finish these up, okay? All right, page 24, question 4. Says a teacher is using this apparatus shown below to demonstrate some of the principles of projectile motion. A launching mechanism, which is mounted on this trolley or a cart, is firing a ball directly upward with an initial velocity of 3.9 meters per second. So I want you in part A to calculate the height the ball rises to above the launching mechanism. So this isn't even a projectile motion question with an angle yet. It's just going to be shot straight up, which means that in part A, I would have a given of a VI being positive 3.9 meters per second. Now, as it goes straight up, it slows down. What is its acceleration, which makes it slow down? Who can tell me? Yep, Nikolai. That is correct. Negative 9.81 meter per second squared. We know at the top, its velocity. What is its velocity when it reaches the top? 0 meters per second. And I'm asking you for the height that it reaches, meaning the D. The D is the height. All right, what equation can we use to get that D value if you know a VI, an A, and a VF? I'll give you all a minute to look at your reference table and figure that out. I'm going to go over my numbers because I realize in red it's probably a little hard to see. Thank you. All right, so what equation can we use to solve for D? Flavia? That is the correct one. Now you have to move it around for D. You have to solve that for D. So to do that, you would get D is VF squared minus VI squared over 2A. We can now go ahead and plug in. So we would have 0 meters per second, which gets squared, minus positive 3.9 meters per second, which would get squared, all over the quantity 2 times negative 9.81 meter per second squared. All right, let me give you a minute to solve that on your calculator. Gavin, can you tell me what you got for that D? That is correct. It goes up 0.78 meters. Very good. Okay, let's go to part B. Part B asks us for the time to get to the highest point. That means our unknown is T. I'm not going to rewrite the givens. They are the same as what we just had in part A. What equation can we use to get the time if we know the VI, the A, and the VF? Miriam, can you give me an equation, please?
D equals VIT plus 1/2 AT squared.
I don't like that one because the VI is not 0. So it means I'd have a quadratic equation to solve, and I don't want you to use the quadratic equation to solve for
Oh,
time.
I think VF equals VI plus AT.
That's better. VF is VI plus AT, which means if I solve that for the variable T, you are going to get VF minus VI all over A. Let's go ahead and do our substitution with units. So that means we would have 0 meters per second minus positive 3.9 meters per second all over negative 9.81 meter per second squared. How much time does it take it to get to its highest point here? And I'm just going to label that T up. What is that time going up? Ryan, can you tell me what you got for your time? Nope. It is not 0.39. Ryder? 0.40, because the digit after the 9 is a 7, so you have to round it up. The time going up, which they asked for, was 0.40 seconds. Okay, let's now look at part C. That trolley gets pushed so that it travels at a steady speed of 1.1 meters per second. In other words, this cart is now going to travel to the right at 1.1 meter per second. And when the trolley gets to point A, the mechanism fires the ball vertically with that initial speed of 3.9 meters per second, which means when this ball gets to this point, it's going to be going horizontally at 1.1 meters per second, and it's also going to be going up at 3.9 meters per second. That's what it's telling you happens right there at point A. In part C, I want you to calculate the distance traveled by the cart before it catches the ball. What does that mean in part C is your unknown? The distance traveled by the cart would be the what? Which way is the cart moving? Horizontally. So what distance am I asking you to find? One. Is range Y? X, that's right. We're looking for D in the X direction. What is D in the X direction? Let's think about what we know. I'm going to do this out of order. What do we know about the X direction always? So think about your X column of a chart. What do we know about the X direction in this question? I'm not going to make the whole chart. I'm just going to list the variables for the X direction. Janicia? That is right. In the X direction, the acceleration is always 0 meter per second squared. What else do we know about the X direction in this problem? Look back at what I gave you here. What else do I know about the X direction in this question? Haley? That's right. The VI in the X direction is 1.1 meters per second. The other thing you should know is now the time. How much time is it going to spend in the air before it gets caught? Nikolai?
0.8 years.
I'm sorry, how much time?
Oh, no, second. I mean,
Okay, so what are you doing to get that?
I was trying to get T out by 2.
That's right. So 2 times 0.40 seconds, which means the total time is 0.80 seconds. All right, now that you have these givens, the A, the VI, and the total time T, you should be able to find the range. What equation can we use to get the range? Shelley, can you help me out with an equation that would have the D, the A, the VI, and the T, please? That is correct. Now, in the X direction, remember the A is 0, so that second half of the equation is going to drop out, which means when we substitute this, we would find that the distance in the X direction is 1.1 meters per second times 0.80 seconds, the total time. Let's go ahead and solve that for the range. Vincent, do you have it?
0.8 meters.
That's right. 0.88 meters is the correct answer. Okay. Questions on number 4. I'm going to cross out part D. Don't worry about that. Just cross that out. We're not going to do that. Let's go then to number 5. And I'm going to tell you in number 5, we're also going to cross out part D and E. All right, in number 5, it says that we have a stunt car driver using a ramp as shown here to jump over a parked bus. The horizontal and vertical components of the car's velocity at takeoff are shown right here. These are the components of the velocity. When I write meters times seconds to the -1 power, that's the same as a meter per second. And this is your VI in the X direction. This is the same thing as 6.9 meters per second, which is your VI in the Y direction. So the first thing I want to know is with what speed the car is leaving the takeoff ramp. Then in part B, I want to know the angle of the takeoff ramp. And then in part C, I want to know how much time it takes for the car to get to the highest point. What am I asking you for in part A? When I say what's the speed of the car leaving the takeoff ramp, what does that mean I'm asking you for? VI. Which means we should be thinking about the triangle that we can construct with these two arrows drawn head to tail. Let's do that. Here is the VI in the X, which is 39 meters per second. Here is our VI in the Y, which is 6.9 meters per second. We are looking right now for that VI, the hypotenuse of that triangle. What equation can you use to solve for the hypotenuse of this triangle? Yep, so that would be a squared plus b squared equals c squared. In other words, it would be the same thing as VIX squared plus VIY squared equaling the VI squared. That's another way to write it. This is side A, that is side B, and that is side C. So let's go ahead and plug in. So 39 meters per second, that's going to get squared, plus 6.9 meters per second, that's going to get squared, and that's going to give you your initial speed squared. So let's go ahead and solve that for the initial speed. Emma, can you tell me what that means the initial speed is? Okay, let's take a look at our sig figs. How many sig figs do these numbers have? Yeah, so what should you round your answer to? 40 meters, 40 point, there you go. 40 point meters per second would be the correct answer with the two sig figs that we need. Okay, part B is asking for the angle of the takeoff ramp. That means if I come back to this triangle, there is the angle, theta. In part B, we are asking you for that angle, theta. Now think about a trig function that you can use to help you get that. Remember, all your trig functions are in the geometry page of your reference table. So if we go here to the geometry section, here are all these equations that we can use to help us find the angle that we're looking for. We've done this previously. Chaudhry? So what equation? You got to give me the full equation.
Change it, A over B.
Okay, in this problem, it's not going to be A over B because of the way I labeled the triangle. Tangent, what are the two sides that are involved in the tangent function?
Opposite and adjacent.
Okay, and so what goes in the top?
So, 6.9.
Opposite or adjacent? Which goes in the top, the opposite or the adjacent? Opposite, right? Because it's TOA in SOHCAHTOA. So we're going to have the opposite side over the adjacent side. So that means you now have to solve it for theta, which means you're going to do the inverse tangent. Theta equals the inverse tangent of the opposite over the adjacent side. Now you can do your substitution with units. The opposite side is which value in that triangle? Is it 6.9 meters per second or 39 meters per second? Alex, which one's the opposite side?
6.9.
That is correct, which means the adjacent is 39 meters per second. So those meters per second are going to cancel. You're now going to solve that. Whenever we do angle problems, we always go to the nearest degree. So I'll give you a minute to work that out. To the nearest degree. Blake, can you tell me what you get? So to the nearest degree, it would be 10 point degrees. There you go. 10 point degrees means the ones place digit needs to be significant. Very good. Okay, part C says, how much time does it take for the car to get to its highest point? That means I'm looking for the time going up. Let's make our chart. What do we know about the X and Y directions? Remember, we always start with our accelerations. Jackson, can you tell me what the acceleration is in the X direction, please? Correct. Elisa, can you tell me what it is in the Y direction, please? Good. Now, we also know our VI values. We also know our VI values. Devin, what is VI in the X direction? Good. And Sydney, what is it in the Y direction? No. What is the VI in the Y direction here, Kiara? And what is the direction of that velocity? Positive 6.9 meters per second. Now let's talk about our VFs at the top, because I just want to get to the highest point. What is our final velocity at the top in the X direction? What is that velocity, Jacob, in the X direction? That's right. It does not change its speed in the X direction. And what is it, Gianna, in the Y direction? That's right. Now you have to think about going up. Going up. I want to know how much time it takes it to go up. What do you think is the better set of givens to use to help you get that time going up? Which one's going to be the better set to use here? What do you think? Khalees? Yeah, because that's where we see a change in speed. So we'll have more equations available to us to help us solve. In fact, anything that involves time in the X direction is not going to work because it's multiplied by an acceleration of 0. It would drop out. You wouldn't be able to get it that way unless you had a distance. So we're going to use the Y set of givens only to help us get that time. All right, let's see if we can come up with an equation to use to help us get that time when we know the A, the VI, and the VF. We know A, VI, and VF. We are looking for the T. Lon? That's right. So if we solve it for T, that's going to give us VF minus VI over A. We can now do our substitution with units. That means it's going to be 0 meters per second minus positive 6.9 meters per second, all over negative 9.81 meter per second squared. So now we can find that time going up. Sydney, can you tell me what that time is? Good. 0.70 seconds for the time going up. And I think that completes our questions, right? Because on the video on Friday, I asked you to watch, you got through 6 and 7. Okay. So we are set here. We have a little bit about time, maybe about 10 minutes. I'd like you to use this 10 minutes now to get started on the homework, which is pages 27 and 28. Those 4 questions, there are 4 questions on pages 27 and 28 are due tomorrow. Like our last show work quiz, you will be able to use the homework to help you with the quiz. So you want to make sure that you're showing all the steps and everything to solve it out. Okay? I'll give you some time now to start working on that.